Hello and welcome to another brief demonstration of the new Bladed Batch framework. In the previous demonstration, we looked at the basic batch features, such as setting up batch jobs from Bladed, running them in the new framework, and then looking at the results of the jobs once they are complete. Today, we'll be looking at something a bit more exciting and advanced. We'll be looking at features such as running your batch jobs across multiple machines in your network, and we'll also be looking at automated failover and recovery, which is a new feature in the Bladed Batch framework. One of the great new features in the new Bladed Batch framework is its ability to set up batches that span multiple machines in your network and the ability to define and control them from a single machine. But before we get into the demonstration, I believe it would be useful to have a very quick look at the topology of the new batch framework. Here is a schematic that provides an exploded view of the batch framework running on a single machine. This is a sort of setup we use to run our batch jobs in the introductory video. So you have a single machine which is running the batch framework. The batch framework is referring to a batch that is defined on the local file system. Then the batch framework kicks off separate calculations, in our case Bladed simulations, when you press the play button. The calculation itself is reading and writing to the local file system because it gets its input files from the local file system from within the batch definition folder, and it is creating output from the simulation on the local file system as well. Now let's see how this configuration can be extended to a setup where multiple machines are involved. Here is a simplified schematic that represents such a scenario where multiple machines are working together to run a single batch. There are a couple of important details in the schematic to draw your attention to. First of all, there are two batch framework nodes in this picture, but you'll note that one of them is identified as a master node, whereas the second one is denoted as a runner node. Although both the master node and the runner node are responsible for running calculations on the machine on which they are hosted, you will note that only the master node interacts with the file system directly. This restriction ensures that all operations that update the batch definition go through the master node, and this is a key component of the design that provides for a scalable system. Now let's take a look at the new batch framework's user interface and see how you can set up and run a network batch with multiple nodes involved. Let me bring up the batch viewer user interface in order to do that. First of all, I will bring up my Bladed instance, select the batch menu group and select view batch within that to bring up the batch viewer. The batch viewer by default is pointed at the default batch folder, which is local to my machine. As you can see, it's on the C drive, but for this demonstration I want to point it to a batch folder on the network, something that I've created previously on the T drive. Now my viewer is pointed at the network batch folder. As you can see, there are about 20 jobs which I've previously created in this batch. Although we are currently looking at a network batch folder, there's only one machine that is part of this batch network, which is this machine that I'm working on. Before we can go on and add a couple more machines to this batch, there are one or two elements of the user interface that I would like to draw your attention to. First among those is the batch settings dialog, which you can access by clicking on this button in the button bar. And there are three settings in here that are of particular interest to us when setting up a network batch. Firstly, the accept jobs from remote host setting should be turned on for a machine to be able to become part of a remote batch. Secondly, you will also need to set up the number of maximum concurrent tasks that are allowed to run on your machine. I've set this value to 5, but by default that value will be set to 2. The process priority setting controls the priority assigned to the calculation process on this machine. If you select it to a value of high, the calculations that will be spawned on this machine will run at an above normal priority, and if you choose low, they will run with a below normal priority. Using this setting, you can control how much resources are available to batch processing on this machine. I will leave the value of this setting at the default and select OK to save my settings. And now onto the Batch Runners tab. This tab lists all the machines that are currently connected to this batch. From this pane, you can find that there is only one machine currently connected to this batch, and it is not running any jobs at the moment. And at the bottom of the batch viewer, you're also informed that you're connected to the manager at a machine identified by the hostname BRVL 400.597, which is also listed as the only runner. This particular machine happens to be the machine I'm doing the demonstration on. Let me now add a second machine to this batch network. You can do this by typing the hostname of the machine that you want to add to the network and pressing the Register These Machines button next to it. As you can see, now we've got two machines listed in the Batch Runners tab over here. You can remove a machine from this listing by selecting the Unregister This Runner. You can also add multiple machines into the runners list by selecting more than one host name separated by a comma. So I've entered two machine names separated by a comma in this instance and pressing the Register These Machines button. So as you can see, now we've got three runners associated with this network batch, and they are all being managed by the batch framework at the node identified by BRVL 400.597, which is this machine that I'm using for the demonstration. This feature that lets you register multiple machines into the batch network remotely makes it really easy to build up large-scale batch networks quite easily from a single machine. You no longer have to log in to each of the machines and start up a bladed instance anymore. Having set up our batch network successfully, let's now run this batch and look at the results from it. I will come back to the job list pane in order to look at the jobs. Please pay attention to the runner column on this pane, which should get populated once I start the run. I will now press the Start Batch button to start the run. As you can see, the runners column is now getting populated with values describing which of the registered machines is running the corresponding job. You can see that the batch has assigned 14 jobs out to these three different runners, which are running 6, 5, and 3 jobs each. And some of those jobs are complete, and the runner is then assigned a fresh job by the manager, which is running locally on this machine where I'm doing the demonstration. You can clearly see here how the throughput of the whole system is improved by all these machines coming together to perform the task. You may even be able to use spare capacity on your machines while you're working on something else. You can clearly see here the power of the new batch framework in action. Now that this run is complete, I want to briefly touch on another advanced feature available in the new batch framework, which is automated failover. So if we cast our eyes back to the presentation that we were looking at for the topology with multiple nodes, you'll have noticed that there is one node which is a master node and another one which is a runner. By automated failover, what batch enables you to do is set up a batch network where one machine will be the masters to start with, but if something were to happen to that machine, and if the batch framework on that machine were to go down or crash, another machine, which at that moment in time is a runner, will take on the managerial responsibility. So let's say if you have a batch network of 10 different machines, you can be guaranteed that if one of those machines went down, something else will automatically, completely transparent to the user, take over managing the batch. So if you're setting off a large batch to run over the weekend, for example, you can be guaranteed that the network will not fall down by merely one of the machines failing during the weekend. The ease of setting up network batches, along with the robustness provided by features such as automated failover, is hoped to make the new batch framework a lot easier to work with, a lot more scalable, and a lot more robust. That brings us to the end of this brief demonstration. Thank you for watching. Goodbye.